Question 5e. A student reacts 35 centimeters cubed of 3 times 10 to the minus 2 moles per decimeter cubed sulfuric acid with an excess of aluminium. We've got the equation there. Calculate the mass in grams of the aluminium sulfate formed in solution. Give your answer to 3 significant figures. Show you're working. So students have always been puzzled by this one, in particular with actually what it is you're trying to calculate. So it's the statement here which always has caused confusion. The mass in grams formed in solution. So what you're looking at here is in the reaction, the aluminium sulfate is being made in solution. So let's imagine you were then able to dehydrate it. You boil the water off and you evaporate out the salt. That is then, if we can then recover all of that, would be the mass that was formed in solution. That's all that means. So don't let any statements like that cause any confusion. End of the day, you're calculating a mass. Whether it's formed in solution or not is irrelevant. You're calculating the mass of this that is made. So what have we got? We've got a concentration and a volume of our sulfuric acid. So from the concentration and volume, I can calculate a number of moles of sulfuric acid. I've got a 3:1 ratio from the acid to the aluminium sulfate, so I can work out my moles of aluminium sulfate, and then from there I can work out my mass. Very straightforward. Give your answer to 3 significant figures. So we've got an instruction on rounding, so be mindful of those, and obviously show the working. So let's have a look at this one then. We've got to work out, first of all, the number of moles of the sulfuric acid. So let's start there. Moles of the H2SO4 is concentration times by volume over 1,000. So 3.00 times 10 to the minus 2 divided times by 35, beg your pardon, divided by 1,000, C times V, over 1,000 gives me a number of moles of 1.05 times 10 to the minus 3. Then ratio, to work out moles of the aluminium sulfate. The moles of Al2SO4 I've got a 3:1 ratio, so for every 3 moles of sulfuric acid, I will make 1 mole of aluminium sulfate. So if I had 6 moles, I'd make 2 moles, and so on and so forth. This is the number of moles I've got. I need to divide, therefore, this number by 3 to give me my number of moles of aluminium sulfate. So 1.05 times by 10 to the minus 3 divided by 3 will give me 3.5 times 10 to the minus 4 moles of aluminium sulfate. Then we need to work out the mass. So if you remember the relationship, moles equals mass over molar mass. Mass is going to be moles times by molar mass, rearranging your 3-part equation. So the mass of the Al2SO4 is the number of moles multiplied by the MR. Now we've not got the MR of this, and this is where the 4th mark comes from, and you don't get this very often anymore. That this question, that you get marks for working out molar masses, because A-level students are expected to know that is a very standard thing to do and therefore not really worthy of a mark. But in this instance, because it's a fairly complicated formulae, you're being credited with a mark for working out the MR. So let's have a look at that first of all. Let's do it as a side calculation. The MR of aluminium sulfate. Well, 2 lots of aluminium. Aluminium is 27. I've got 3 lots of sulfur at 32.1 and 12 lots of oxygen. 4 times 3 is 12. So add that all together, so 12/16. The molar mass of aluminium sulfate will come out at 342.3. Okay, we just reiterate that one. 2 lots of 27, 3 lots of 32.1, and then 12 lots of 16. Gives you 342.3. So, number of moles, 3.5 times by 10 to the minus 4, multiplied by 342.3, gives me an answer of 0.119805. That's just rounding just with the answer on the calculator. We want to answer 3 significant figures. So my 3 significant figures are there. Remember, you don't count a 0 point as significant. If it's 0.00, those zeros there aren't significant. It's the first number that isn't 0 after the decimal point. Okay, if you've got a 10 there, then the whole thing is significant. Obviously, we haven't got that. We've got 0.119805. So 3 significant figures. It's going to round this up to 0.120, and that will be your final answer in grams. 0.120.